Okay, so today I'm going to be talking about creating materials for the future of nuclear fusion reactors. So, you might be wondering why nuclear fusion reaction is not being used today. The answer is quite simple. Currently, we do not have a containment method that can sustain the conditions required for nuclear fusion reaction. So this reaction can occur commonly in space since the conditions are ideal. So for example, we can talk about on Earth. Relatively on Earth, the temperatures are very low, and the pressure is also relatively very low compared to other areas. So low temperature and low pressure. In space, for example, let's say, for example, the surface of the sun or any star, for example, the temperature is extremely high and pressure is extremely high due to all the atoms present in the sun. So we have high temperature and high pressure. So the conditions required for nuclear fusion to occur are very high temperatures of about 100 million Kelvin and very high pressure in addition to the time required for the process to occur. So after researching many different types of materials, it was found that a composite material consisting of steel, tungsten, and copper had the most promising potential for this application. So composite materials are essentially combining two or different materials with different properties to create a new material. It was also found that this method that was used to create these materials can also alter its properties greatly. So the two main methods that are currently being studied today are sintering and microstructuring. So sintering is essentially the process of fusing powdered material through extreme heat and pressure. Nanopowders, which are selectively creative enhanced powders, are usually the material chosen for this process to occur. So, without sintering, when we create a material, for example, let's say element 1 would be represented by a circle and element 2 would be represented by a square. So, without sintering, it would be very random. Just a random dispersion of elements. It could be in any configuration, which is not ideal and not optimized for any desired output. So as we can see, squares are randomly distributed, not really even or selectively anywhere. So with sintering, due to the extreme heat and pressure present within this process, all the room between atoms would be taken up by any atoms if possible. So as we can see, all the room between E1s are filled up with E2, which causes all the elements to be very close together, which increases its density and optimizes its effectiveness. So, through this process, it increases its strength, density, and overall thermal conductivity of the new material. This method is the most effective method of making the composite in the optimal ideal configuration, and it causes the least impurities throughout the material. So, another method being researched today is called microstructuring. It is similar concept to that of sintering, however, depending on the location of the material, it would have different properties. For example, if we had a sample material over here, even though the material would be made up of the same elements and materials, we can say the left side and right side would have very different properties. So, the first step of this process would be getting these nanopowders at very high heat, similar to sintering. However, when this process occurs, an electromagnetic or an electrostatic field is introduced. So, with microstructuring, we would have an electromagnetic field, for example. We have the positive terminal and the negative terminal. So, as we can see, the force travels from the right side to the left side. So, we can say E1 is conductive, and E2 is not as conductive. So since it's conductive, it would be attracted a lot more to the positive pole. So we have circles over here, and we would still have circles within the entire material, but a lot more towards the end of the positive pole. Since E2 is not as conductive, it would be evenly distributed throughout the material. So this is more ideal for when you want to make a material with different uses on different ends. So these are two different methods for creating materials that are composites, and I hope this was very informative on how we can make composites for the future of nuclear fusion reactors.